Hola! All right, today we're doing section 7.3, which is all about what is called trig substitution. Take two of your favorite things, mix them together, you get something better. With everything except baseball and statistics, because that kind of that's gross. Somehow putting chocolate on chocolate makes it, I don't know, gross. Like chocolate on ice cream makes it vomit or something. I don't know. So, but this is not the case this time. We love substitution. We love trig. Let's have some fun. So here's the game. If you have an integral that has this guy in it, and it will be always written as a squared minus x squared. If you have something like this, the trick is, my friend, to let x equal a sine theta. Why, groom? Hey, I'm glad you asked. Check it out, dog. Because, well, of course, dx, well, let's just go with this, is going to be a cosine theta, d theta. And you're like, well, wait, what? Well, just keep with me, bro. I got you. Here's the game. So, this becomes a squared minus a squared sine squared. Yes? And, of course, here you're going to replace this with a cosine theta, d theta. And so you do this, and you're like, wait, Mr. Grimm, can't you factor in a square? Oops. Come on, stupid. Get with the program. Out of that, well, you sure can, Tyler. Nice job. Attaboy. I'm proud of you, son. Good work, boy. Nice. But wait. Hold the phone, Jack. 1 minus sine square is cosine square. Dude, that's hot. And so this becomes a square cosine square. And of course you get a cosine theta. D theta still tagging along. And you're like, wait, what is the square root of a cosine theta? Well, it's a cosine theta times a cosine. You get this thing. Ta-da! And so this whole time, now you've got rid of that stupid radical. And you're like, bro, I got this. Well, of course you got this. Now you recall. You're like, wait, isn't that 1 minus sine squared? No, for gosh sakes, don't do that. That's stupid. That's stupid. So you may recall, or you may not recall, that cosine of 2, get with the program, Jay. The cosine of 2 theta can be written a couple of different ways. First of all, it can be written as, well, one we're not going to use. I'm not going to write that. But it goes here as 2 cosine squared theta minus 1. Or it could also be written as 1 minus 2 sine square theta. I'm going to look at the top one. If I solve for cosine square, I will get cosine of 2 theta plus 1 all over 2. Am I right? I feel like I'm right. And so if you do that, okay, I'm going to pull this a square and the 2 out front. That's going to give me cosine of 2 theta plus 1 d theta. Bro, I got you. That's a square over 2. From whence did cosine come? Well, it came from sine, of course, but of course over 2, because you do a little substitution there. I'll let you play the game. Oopsie daisy. And so you have this scenario plus c, or if you have limits, you can integrate it at that point, of course, and it's quite straightforward. Could I, groom? Is it possible that I could, if I wanted to, come back up here and go, let's look at this. What is x? Bro, I can. Check it out, dog. X is, well, come on. Go with me now. Theta is, by definition, x over a. So theta is the arc sine of x over a. And so that goes in there. And then there's your answer. You know, if you're going to get back to x's, and then, of course, the sine of 2 theta, you're like, wait, how would I relate that? Okay, we'll talk more about that in a minute. This is the game. That's how we're going to play it. Okay, now I will say this. The sine of 2 theta, these are a couple of trig identities that you're going to need to remember if you don't have them in your brain. This one's kind of a big deal. 2 sine theta, cosine theta, like that. Okay, but that's the idea. Now, when we do this problem, we're typically, when we go back, we'll work backwards. We'll put back the x's in. But it's a big deal. Again, because we had this, we are going to make this substitution. Give me another one, groom. Gosh, I'd love to. If you have one that looks like this fella, if you see this guy in a dark alley, Run fast. X squared plus 1. Wait, hold on. X squared, isn't that, not x squared plus 1, x squared plus a squared. I was going to say x squared plus 1 is tangent. Oh, dude. What if we let x equal a tan theta? Then dx would be a secant theta, squared theta, d theta. And so you'd replace this with, again, a square tan square plus a square. And the same thing happens every time. Tan square plus 1. Of course, you can pull that out front. Tan squared plus 1, by definition, let's write this down somewhere. You recall cosine squared theta plus sine squared theta is equal to 1. True dat, homies? True dat? If I divide everybody by cosine square, that's the cardinal rule of algebra. Whatever thou doest to one side, thou must also doest to the other side. 1 plus tan square equals secant square. Meaning I could replace this with secant squared. Dude, what's the square root of that's it, baby. And now you're home free. Okay? That cute little trick will do quite a bit. And then there's one other one, which I will throw up real quick. This sucker. This one here. Now, this one here, I'll be honest with you, this is not the one that sticks in my brain. I always have to look this one up. The first two always stick with me. This one looks, what do I do, Groom? Well, I mean, you're going to let x equal a secant theta. And so dx is a secant theta tangent theta. D theta. And so this is a secant, a squared, secant squared minus a squared. And then, of course, you pull the a squared out, and you get secant squared theta minus 1, which is, from that same one we just did a minute ago, is tangent squared. And so this becomes a tan theta. Those are the three things that we'll be doing. That's it. That's all. Okay. So you need to identify which of these fellers do I have. Do I have this one? X squared plus a squared or a squared minus x squared. Those are the three possibilities for trig sub. That's it. If it's not one of those, what are we going to do? Okay. What you'll notice here on these problems tonight is, had there been something like this, let's say there was this guy, you're like, oh, dude, I know this one. This is going to be secant. Just hold the phone, bruh. If you had this guy, this is a straight substitution. Why? Well, because the derivative of the inside, boom, he's right there. You with me? Boom, he's right there. Okay. All right. So some of these are going to be like, oh, could we do it a different way? Yeah, actually you can. Some of them you can actually do trig or the other ones. In fact, there are several that can go either direction. Okay. Integration by parts group? No, this would not be an integration by parts because it would be an infinite a mess. In other words, it would not go away. It wouldn't be cool at all. And so, no, you would not in that one do that situation. Now, let me do some examples here today. And as we do them, you're like, oh, I got this. For instance, this fella right here, 0 to a half. Aight. And x squared over 1 minus x squared, square rooticated. You're like, ooh, regular substitution. There's my u. Not so fast, Haas. This is not du. Oh no, what will I do? We're going to use trig substitution. And because it's of this format, where a is 1, you're going to let x equal 1 sine theta, and dx will equal cos theta. And so now you're going to go, oh, okay, well, that's sine squared. That's bitchin'. Over 1 minus sine squared, square rooticated. And you're like, oh, wait, 1 minus sine squared is cosine squared. Sure is. So you end up with sine squared theta over cosine theta. And then you're like, wait a minute, I've seen this story before. That is 1 over cosine times tangent. Or if you prefer, and I do, well, that's secant tangent. Wait a minute. Hey, who is he the derivative of? Well, he's the derivative of secant theta. Ta-da! So you're like, Groom, that's my answer. No, I'm afraid not, sir. I'm afraid not, good sir. You're close, though. I'm proud of you. I'm proud of you. Remember, these are x's. We need them to be thetas. Are you with me? We need them to be thetas. Well, how do we do that? Well, we need to solve for theta. So the arc sine of x is theta. So what angle, if you plug 0 in here, the arc sine of that is 0. So that's cute. If you plug a half in, why, that is pi over 6. And so you'll plug those values in. 0, pi over 6. And so, I don't know, secant is 1 over cosine. 1 over cosine is 1. And so there's that. And then pi over 6, the secant of pi, well, let's see. The cosine of pi over 6, cosine of pi over 6 is root 3 over 2. And so the cosine would be 2 root 3 over 3. Whatever that is. That's cute. Yay! And the crowd goes semi-wild. This is about 3.4. This would be 3 over 3. So about 1.4 over 3. 0.49-ish. I don't know. In that ballpark. Okay, I'll let you do the math. Mr. Groom just doesn't care anymore. It's Friday. Well, it's actually Thursday night as I'm recording this, and I don't care anymore. I just don't. Let's do this one for fun. Oh. Ew. So they said, here we go. Let's go from a half to 1. Little dx on top just to freak the kids out. Little x squared here. Little squirt of x squared plus pho. Because it's of the format x squared plus a squared, we're going to let x equal 2 tan theta. And so dx is 2 secant square theta d theta. And so the top now becomes 2 secant squared theta d theta. This is going to be 4 tangent squared theta. And then this is going to be 4 secant, no, 4, come on, dummy, get with the program. 4 tangent squared theta plus 4. As per usual, this is 2 secant squared theta d theta, 4 tan squared theta. Now this, take a 4 out, you get tan squared plus 1. Hey, that's secant squared. It sure is. And what is the square root of 4 secant squared? It's 2 secant theta. Now we're just dadgum home free. Whoosh, 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 whoosh. And you end up with, pull that 4 out front because I'm tired of looking at it. And you end up with 1 over cosine. Now this is sine over cosine on the bottom, but it's on the bottom, so it's really cosine squared over sine squared. Don't forget your thetas, you look an idiot. There you go. Nice. D theta. Whoosh, whoosh. Now this is a cute trick, friends. My friends, this is a cute trick. It's cosine over sine times 1 over sine. How did you know, Groom? I don't know. Been here, done that. Got the t-shirt, as they say. This is cotangent, cosecant. Oh, dude, I've seen this cat before somewhere. Isn't that the derivative of cosecant? Ah, you're close. It's actually negative cosecant. But you're right. Good job. Negative cosecant theta. Okay? Remember, the derivative of cosecant is negative cotangent cosecant. So we didn't have the negative, so you know what I'm saying. And now we got to evaluate. And again, I need to know, so then that's x over 2. Arctan is theta. Yes? And so if we put in this, put in a quarter into there, arctangent of a quarter then, let's ask Betsy. Oh, Betsy. We don't want to be in degrees, for goodness sakes. That's just embarrassing. Oh, dear. That's terrible. Loser. Arctan 0.25 It's basically 0.24, about 2.245 on the bottom end. And on the top end with the 1/2 then. So 1/2 is a half, last I checked. 0.46-ish, whatever. So 0.245, 0.46-ish. Yay! And now we simply give it this number here. You're like, well, how do I do cosecant on the calculator? Isn't there a thing in the catalog? Listen, that just makes me angry. Please don't do that. Here's what Mr. Groom is going to do. I'm going to go sine 0.46. Ta-da! And then we do 1 divided by that. So I'm going to get 2.25 on the top end. And on the bottom end, I'm going to get the sine of 0.245. And then 1 divided by that is 4.12. And then you're done. Finish the job. It's that easy, my man. It is that easy. Groom, couldn't I find cosecant of theta? You could. It's weird. In other words, you could, in a triangle, kind of figure some of that out. It's a pain. For instance, you know in this triangle up here that x/2 is the tangent of theta. Right? You know that to be true. Because opposite over hippopotamus. And then, of course, this is going to be x squared plus 4 square rooted. Oh, dude, no way. Yeah, bro. That's where it comes from. That's where it comes from, bro. And so if we look at this problem, what a guy could do is when he gets to right here, come with me now. Oh, go with me now. Right, see that? We good? And so my cosecant is this fella over that guy. So it's the square root of x squared plus 4 over x. That's the cosecant, right? And I have negative 1/4 of that. And now you could simply plug in the values in question, which were 1/2 and 1. And, I mean, if I've done it correctly, I get the same answer, I suppose, yes? So, negative 0.25. Squirt x squared plus 4 divided by x such that x equals 1. And then I do this such that x equals 0.5. And I take this fella minus this fella. And I get that. 0.47. And maybe I should do it down here just for grins. 2.25 minus 4.122 times negative 0.25 is... Isn't that what I just had? I feel like that's what I had a minute ago, isn't it? 0.47. Yeah, 0.47, 0.468. Yes, close enough for government work. It's good enough for government work, as they say. Nice. All right, let's do another, shall we? Now, on this next one, bruh, there is no limits of integration. Oh, no, what are we going to do, Groom? But it's going to make my life easier, actually, honestly. 12 plus 4t square rooticated dt. Okay, cool. I see a plus. That strikes me as tangent. Tangent. Groom, can we pull a 4 out of these fellers first? If you would like, you may do that. Do I have to? You don't. Can I? Sure. I think that's what I'm going to do. And pull a 4 out when it becomes a 2 out front. Because it's outside the radical when you do that. So you square root it. And so I'm going to say that t is equal to root 3 tangent theta. And dt then is equal to root 3 secant squared, you moron. Secant squared theta d theta. Cool. Now, let's play the game. So it's 2 square root, and this is going to be 3 plus 3 tangent squared theta. And then dt is square root of 3 secant squared theta d theta. Remember, this is going to be 3 secant squared theta inside a radical, yes? And then root 3 secant squared theta d theta. So this is going to be the square root of 3 secant theta, square root of 3 secant squared theta d theta times 2. Pull that's going to be 6 out front, secant theta cubed d theta. Then what, Groom? Well, we'll play that here in a second. But you got me there? Okay. Nice. So we haven't integrated yet. We just made it to where it's quote-unquote possible to integrate. Just a second. Now, on this problem here, a guy might go, well, I don't know what to do. You do. This is secant theta times, come on, stupid, secant squared theta d theta. This looks like an integration by parts problem. Well, Groom, what should I do? Who should be my u and who should be my dv? Well, truthfully, I don't think it matters a whole whale of a lot. I would probably do this, and I'd probably do this. You can actually, I think, get there both ways. But this is tan theta. That makes me happy. Yes? Oops, tan theta. And then this guy, this is du would be equal to secant theta tangent theta. Okay? D theta. Is that what I wanted to do? I think so. Let's try it and see what happens. Okay, so secant. And so, of course, it's uv, so secant tangent minus the integral of v du, so that is tan squared secant d theta. Nice. And you're like, hey, let's do it again, right? Yeah, probably. Hold that thought in it. You're like, Groom, you kind of made a muddy mess out of this. Kind of, but not quite. Remember, this can be written differently, yes? So it could be 6. I'm going to write this as secant. Remember, this 6 goes all the way across, correct? Okay, we got a 6 all the way across this thing. 6 secant theta tangent theta minus 6, and then the integral of, now, tangent squared can be written as secant squared theta minus 1 secant theta d theta. If you distribute this, you get this. So I break that into 2 parts. Right? That's handy. That's handy, Groom. Nice. Now, what did this whole thing equal a minute ago? Well, the whole thing equaled a minute ago, if you recall, 6 secant cubed theta. Right? Does that make sense? And so what we're going to do is we're going to add this fellow to the other side. We're going to end up with 12 of them. Is equal to, now this part here didn't change, so we're just going to go ahead and write that down. And then this piece here, now listen, how do you do that? Well, that's 1 over cosine. What is 1 over cosine? Oops, there should be a 6 here too. Well, that's the same thing as saying 6 cosine of theta to the minus 1. Well, actually, before you do that, let's do that. Bless me. Woo, Lord. D theta. And you're like, wait, what if u is cosine of theta? Oh, I don't know. What about it? Then this would be negative sine theta d theta. Well, then this would be 1 over u. Well, that's ln, Groom. It is. So it's going to be 6, negative 6, actually. ln of the cosine of theta, right? Times sine of theta d theta. Okay? And yeah, that's that. Not that. No. Hold on. 1 over cosine theta d theta, right. Hold on, I'm working here. So that's going to be 1 over u hold that thought a minute. Hold that thought. That's in the back of the book. That's one of the ones that you're supposed to know. You're supposed to know to go look it up, I should say. So we haven't got to that part of the book yet. We are coming to that later. There's a whole section on, well, you get to go look at a table. Isn't that cool? That's one that you'll have to just, you don't memorize it, you just do, you look it up. 1 over, the integral of secant is, it has an ln in it. Integral of, oh, come on, Jay, secant x. It is, oh, sorry, yeah, secant x plus tangent, ln of secant x plus tangent x, that's right. So this piece here is plus, so it should be, what did I say it was? Plus, yeah, so yes, it's just at positive. So over here it was negative, so minus 6 ln of secant x or theta plus tangent theta. All right, cool. And then divide everybody by 12, yes? Right? Now that's an ugly one. I'd never make you do that one like that all by yourself because it's just too gross and ugly. Okay. But here's the gross part. You're not done. Well, what do you mean I'm not done? Well, bro, they didn't give any limits of integration, so you can't just stick things in. Are you freaking kidding me? No, I wish I was, sir. I wish I was. No, here's theta. Here's t. Here's squirt 3. That's the tangent. This is square root of t squared plus 3, which is what I have in there. Nice. So you know it's right. Okay, so the final answer is I want secant tangent. Well, secant is t squared plus 3 over root 3. Tangent is, where's my picture? Is t over root 3 minus the ln of secant, which is this thing, plus tan, which is this thing, all over 2. That's your final answer. Okay? All right. Again, ugly, but that's how life goes. All right. I'm having fun. Let's do another one. Do one more, Groom. No, I'm going to do 5 or 10 more because I want to, because that's how I am. Groom, does it have to have a square root on it? No, not always. So this one here, for instance, can come to mind. X squared minus pho to the 2nd power. Sweet! Because it's of this format, x is going to be equal to 2 secant theta. So dx is 2 secant theta d, come on, dummy, tangent theta, d theta. Awesome. And so you're going to have 2 secant theta tangent theta d theta over 4 secant squared theta minus 4 to the 2nd power. Awesome sauce. Nice. And so you're like, what do I do with those 4s? Well, I factor them out, yes? So I can write this as 4 secant squared theta minus 1 squared. Oops, squared. And you're like, wait. So this piece right, oh, damn it. So this piece right here is tangent squared. It is. So you have 4 tangent squared. So you're going to have 16 tangent to the 4th on the bottom, yes? And on the top, you're going to have 2 secant theta tan theta. That's cute. And so this becomes 2, 1, well, it's actually, let's be ridiculous here. It's 1/8. And so this ends up becoming 1 over cosine times, and then this is going to be cosine cubed over sine cubed. True dat? True dat, homie. And you end up with this thing. Now you're like, wait, what is that exactly? I'm not sure that I recognize him. Well, we got this. It's going to be 1/8. And so you're going to end up with, well, I see cosine squared over sine squared, which is cotangent squared, right? And then there's an extra 1 over sine. Do I like that? Maybe. Do I? I don't know. I just work here, bud. Wait. Yeah. Maybe. Sure. I guess. So I look at that and I think to myself, all right, well, hold on. It's cosecant theta d theta. You're like, Groom, I have a question. Yes. Should we use integration by parts? I think you could, but let me suggest that we do substitution. What if u is cosecant theta? What is du? That'll be negative cotangent squared theta d theta, right? Am I right? But I have negative. I got, yeah, no, I don't have that. So I have this, right? So this looks like negative 1/8 the integral of u du. So that's just u squared, right? So negative 1/8. That's u squared, so cosecant squared over 2. So negative 1/16 cosecant squared theta, right? Right? That's your final answer. Now, let's come back up here. I need a picture. Well, my picture says that x over 2 is secant. I don't like that, Groom. Fine. Then this is 2 over x, right? Cosine. And this side over here then is going to be the square root of x squared minus 4. No stinking way. And so our final answer is cosecant squared. So it's going to be x over x squared minus 4. X over x squared minus 4 squared. So look where we started. We started with that. We ended up down to here. Now, how do I know if that's right or not? Well, to be quite blunt with you, I don't want to do it, but I take a derivative, I suppose. That's the quotient rule, right? Don't forget your 16th, but let's go with it. The derivative of the top is this times the bottom minus the top times the derivative of the bottom all over the bottom squared. So that's 2x cubed minus 8x, 2x cubed minus 8x minus 2x cubed all over x squared minus 4 squared negative 1/16 when it's all said and done. So it's going to be negative, so it's positive. Positive 1x, now that's a little screwy because we shouldn't have an x left on top, over 2x squared minus 4. So what does that tell me? So it tells me I screwed up somewhere, doesn't it? Okay. It tells me somewhere I made a little bit of a boo-boo. Okay. Just a hair of a boo-boo. Hey, boo-boo. Let's get a picnic basket. All right, one moment, please. Okay, I see my boo-boo. Okay, this is all good to hear, and then we went kind of cross-eyed right here. So what you end up having here then is 1/8. You got an extra sign, so it's 1 over sine theta times cosine squared over sine squared. There we go. And so this is cosecant cotangent squared. And what is that? The antiderivative. We already did that tonight. We said that was negative the cosecant theta. Okay. Now the cosecant of our boy theta again is this, and so like so. So x over 2 is the secant, or 2 over x is the cosine. Sorry, 2 over x is the cosine. Get it right, dummy. There you go. And so we want the cosecant. So that'd be x over, so it'd be negative 1/8 x over the square root of 4 minus x squared. Let's see. Okay, and then you can try, see if that's right, I guess. So, because I'm a nice guy, I'll do it. So, that's going to be the derivative of the top, 1 times the bottom. X squared minus 4, isn't it? Minus the top times the derivative of the bottom, which would be 1/2. Over the bottom squared. So it's x squared. So you end up with, well, I don't know. We'll see if Groom can pull it off. He's kind of not the sharpest tool in the shed some days, but he's all you got, man. Groom, he's our man. If he can't do it, no one can. It's going to be x squared over the square root of x squared minus 4 over x squared minus 4. All right, let's get a common denominator upstairs. And so if you did that, you would end up with, don't forget your negative, stupid. You'd end up with x squared minus 4 minus x squared over x squared minus 4. Square root x squared minus 4, like thus. And then you end up with them going away. That's nice. Something is not quite right, dadgummit. One moment, please. Yeah, I'll be darned if I'm holding my mouth right on that one. Well, what I want you working on today in class, I'll try to get there, figure out what I did. I know I said about the other problems too. Mr. Groom he's a little busy. He's a little overwhelmed some days. Let's do 5 to 21 odds, except for 13. Those all should be doable for you. So work those out in class. Work together, for heaven's sakes. And I will see you, I don't know. I'll see you when I see you. Tuesday, probably, if you're lucky.